Greetings, Calc 3 students. This question is from section 14.7, and it's question number 2 on our homework, but it also corresponds to the exercise number 14 from our book. So we're tasked to find all the local extrema for this particular shape. And so remember, that means that we're looking for the max, the min, or any saddle points. And there can be more than one saddle point, so sometimes they write it like saddle points, more than one. So our strategy is to first take the partial derivative with respect to x and set that equal to 0. So when I take the partial derivative with respect to x and set it equal to 0, I get the cosine of x, take its derivative as negative sine, so minus 6y times the sine of x, but with a negative out front. And then I'm going to take the partial derivative with respect to y and set that equal to 0. So when I take the partial derivative with respect to y, I get 6 times the cosine of x. Now I need to solve each of those for 0. So first, I have negative 6 times y times the sine of x equals 0. And when I solve that, I get y equals 0, or the sine of x equals 0. And where does the sine of x equal 0? Well, if I look at this unit circle, and there are two places from 0 to 2 pi where the sine of x is equal to 0. That's where the output of the unit circle is equal to 0. So those two places. And so I have x is equal to 0 or x is equal to pi are the two places. And then also, of course, y is equal to 0. And then second, I have to look at where does 6 times the cosine of x equal to 0. So when I solve that, I get cosine of x is equal to 0. So I'm asking myself the question, where is the cosine of x equal to 0? So this is input. Cosine is input, right? So it would be these two places where I would be equal to 0. And so that is x is equal to pi over 2 and 3 pi over 2. So those are my points that I need to check. I've got a number of them. I got 3 values from the partial derivative of our function with respect to x, and I got, that's those 3, and I got 2 more from the partial derivative with respect to y. So then what I need to do is find, depending on how you look at it, but I'm going to find sometimes what's referred to as the Hessian, or the determinant of the Hessian. And so that is this matrix f of x derivative first, then x again. Then in the next to that, f of x first, then y. Then f of x first, then y, and then f of partial derivative of y, and then take its determinant. And the thing of it is that for some of us, we have not taken any linear algebra yet. And so what our book does is just call this a capital D, evaluated at x and y. And then they actually multiply out this determinant for us. So that's the partial derivative with respect to x twice, multiplied by the partial derivative with respect to y twice, and then minus the partial derivative of x and y, x first, then y second, and square that. And so that is that means the same thing, right? So if you've taken some linear algebra, this determinant of this matrix would work out to be what is down here. But not all of us have that, so we just sort of show both ways. Okay, so I have to plug in the values then. I need to find out what is this? F with the first derivative with respect to x and the second derivative with respect to x. So I'm going to make a little chart over here so I don't forget. The first derivative with respect to x, well, I've already done that, and that is negative 6 times y times sine of x. So negative 6 times y times sine of x. And the first derivative with respect to y is 6 times cosine of x. 6 times cosine of x. So I'm going to take the derivative of this function a second time with respect to x, and when I do that I get negative 6 times y times the cosine of x. Then I also need to do x first and then y second. So x first and then y second, so I'll have negative 6 times the sine of x. Negative 6 times the sine of x. And then I'm going to do y first and then x, but those should be exactly equal to x first and then y, but I'm going to check it out. So if I do y first and then x, I should get 6 times the cosine of x, take its derivative, would be negative 6 times the sine of x. So they are indeed the same. I was just checking. And then y first and then y second, I get 0. So those are my 4 second partial derivatives. And then I just plug them into this D formula, or the determinant of the Hessian. So I get negative 6 times y times the cosine of x, and then times 0, and then minus, and I get negative 6 times sine of x, and square it. So I'm putting this value in for here. That's what the formula says to do. And I multiply up times this value in for there. That's what the formula says to do. And then I'm subtracting. And then I take the partial derivative with x first and then y second and square it. So that's what these are. I put them right there. So when this simplifies, I get this d is equal to 0 minus 36 times the sine squared of x. And so I could write this very fancy. I could write d evaluated at these points of x and y that I'm interested in is equal to minus 36 sine squared of x. And so we have a little chart in our book, and it says if d is bigger than 0, or if d is bigger than 0, these are maxes and mins. And if the partial derivative of x first and then x again, if that's bigger than 0, we have a local min. And if the situation where it's less than 0, we have a local max. And if our d is less than 0, we have one of these saddle points. By the way, it's not on the chart, but it is also true that if d is exactly equal to 0, then we don't have any idea what's there. That doesn't mean that nothing is there. It just means this technique won't help us to figure out what's there. Okay, so let's take each of our points and plug them in and see which of these categories we fall in. So our first point that we found is y is 0 and x is 0. So the point 0, 0. That's the first one. So let's do that one. So this would be the d evaluated at 0, 0. And when we do that, we'll get minus 36 times the sine squared of 0. And the sine of 0 is 0, and 0 squared is 0. So the end result is 0. Okay, so we're not really sure what's happening at that point, 0, 0. So then the next thing we're going to look at, the next point is x is equal to pi, y is equal to 0. So let's plug in that point. So D evaluated at pi, 0. And we get negative 36 times the sine squared of pi. And the sine of pi is 0. And when I square it, I get 0. So the result will be 0. So once again, we fall into this D equals 0 situation. And we're not really sure what's happening there using this technique. So then we're going to walk into our next group of points, which are from down here. So we did these two. Now we got to do these other groups. So we know that x is equal to pi over 2. So D evaluated at pi over 2. But what do we put in for y? Well, as it turns out, there are endless possibilities for y, right? But we are told to choose things on the interval from x is equaling to 0 to x is equaling to 2 pi. So I'm going to look at the extreme of that. So when x is equal to pi over 2, well, my y is going to be, at the extreme, would be 0. Or I could use 2 pi, right? But 0 and 2 pi are the same thing. Cosine of 0 and the cosine of 2 pi are the same thing. So I'm just going to use 0. And so when I do that, I get minus 36 times the sine squared of pi over 2. And the sine of pi over 2 is 1. And I square it, I get 1. And I multiply that by negative 36, I end up getting negative 36. And negative 36 is certainly less than 0. And so we have a saddle point happening there. So when x is equal to pi over 2 and y is equal to 0, and what does my z equal? Well, the z equals 6 times y, which is 0, times the sine of pi over 2. And the sine of pi over 2 doesn't matter because I have 6 times 0, so that's equal to 0. So I have at the point pi over 2, 0 comma 0, I have a saddle point. Then we have to check what happens with d at 3 pi over 2. And by the same idea, I'm going to use the extreme point that we're given on our interval of 0. I could use 2 pi, but that would be the same. Cosine of 0 and cosine of 2 pi are the same. And I am getting that 3 pi over 2 from this second situation where we found 3 pi over 2. Okay, so I plug those values in. And what do I get? Well, I get minus 36 times the sine squared of 3 pi over 2. And 3 pi over 2, when I take the sine of 3 pi over 2, I get negative 1. But negative 1 squared is positive 1. And positive 1 times negative 36 is negative 36. So once again, negative 36 is certainly less than 0. So that means I have a saddle point. And x is equal to 3 pi over 2. Y was equal to 0. And so then the question is, what is z equal to? So y was equal to 0. So then z is equal to 6 times y times the sine squared of x, which is 3 pi over 2. And once again, this is equal to 0. So then I have this other point of 3 pi over 2, comma 0, comma 0. I have a saddle point. Our homework asks us, where is the min? And we didn't find any min, so we're going to put DNE. It tells us to put DNE when none exist. And then the max, and we didn't find any maxes, so we're going to put DNE when none exist. And then saddle points, it tells us to enter with a comma. So we found 2. One was at the point pi over 2, comma 0, comma 0, and then a comma. And the other was at the point 3 pi over 2, comma 0, comma 0. Okay, if you have any questions, let me know.